Okie dokie. Welcome aboard. It is pretty close to the end of my jam. Let's have a look at EngJam. It's the last day. So I guess I've got a couple hours tonight, and then all tomorrow, and then submitting at midnight. No one has entered yet. I kind of imagine that it'll just be me, or me and one other entry. Didn't get a lot of discussion inside the jam over the course of the competition, but I've been spending a lot of time on my project, which was always my primary goal for this endeavor. So, where am I at? Let's start with the log. See how much I can catch up with. Let's see. Maybe go back to Wednesday or Thursday. So I've made several commits since then. What is that? 2, 3, 4, 5, 6, 7, 8, 9-ish. And the main theme has been I have finally started to get some traction with my Python objects and even getting them to interact with each other a little bit. And the thing I'm working on now is an iterable class. Let me show you. Also, I switched to Vim, which is my kind of my normal editor for like editing configs, because Lapsy or Lapska or whatever, however you pronounce that text editor, it was putting garbage text into my files and causing syntax errors. So I switched back to Vim. I have like no plugins for C++, but everybody aboard the struggle bus, I guess. And let's see, where do I need to show this? Let's check scene. This is the implementation. No, this is the header, isn't it? So it all comes down to this guy. And what I had before was a vector of drawables, or a vector of pointers to drawables. Either way, the idea was that in C++ I can write, here's a new drawable, add it to the vector, and the scene will iterate over it to draw it. But what I wanted was to be able to make instances of that drawable item, whether it's a box called a frame, a caption, or a sprite, and I wanted to be able to give those to Python, or I wanted Python to create them with a simple exposure of that class, and a specific method for the McRogueface API could add that to a scene's vector, and then the object you created in Python would be drawn every frame by C++. So to accomplish that, basically all of my Python containers, they hold a shared pointer, and so does the scene, or so does the UI frame, because this is the exact same data structure for children, for recursive nested frames. So that became, instead of a vector of UI drawable, it became a vector of shared pointer to UI drawable. And the magic behind that is, if I make it from C++, Python can borrow it. That's two shared pointers. If the C++ code deletes it out of the vector, that deletes one reference, but Python doesn't get a dangling pointer and a segmentation fault because the shared pointer ensures that the memory stays allocated. It's not drawing anywhere, but that's actually kind of a feature because theoretically Python could take that same UI drawable, the whole menu, all the children on it, the entire on-screen widget, and move it to another scene even. So this would be a way for Python to hold drawable widgets and move them between scenes. Great, but I also want to have the ability to look at all of the UI elements in a scene, or all of the UI elements that are children of a frame. So I got to writing my iterator class, which is definitely the biggest thing I've bitten a bite off of with a Python API. But that caused this whole thing, the vector to pointers to drawables, to be wrapped in its own shared pointer. I don't really have a like a use case in mind. Like, I do think that scenes maybe could say that once they're created, they are never destroyed. But I don't know if that's how people will use the engine. Maybe someone has some a use case where they need to create scenes on the fly, or they want to dynamically generate a lot of them. I don't want to put a box around that just yet. So I've done the same pattern again, which is take that object, wrap it in a shared pointer, and now I can share this entire container with via a Python class to expose the collection. And that's great. That's not very thoroughly tested, but it does seem to compile right and more or less do what I want it to do. All the work so far really has been in UI. So let me go to that. And I have this new method that I just finished up. And the idea behind that is any Python object I've defined, whether it's a UI frame, a UI caption, or a UI sprite, those derived classes, I need to be able to take a pointer to a UI drawable, like is held in those containers, and figure out what the actual type is, because in Python, that UI drawable has all different fields depending on what the actual derived class is. So a frame object, a caption object, and a sprite object have totally different methods, different members to interact with the text that's on a caption or the image that's on a sprite, that kind of thing. So to enable that, I needed to write this function that will reach out to these types, and they will all have a function called derive type. And all it does is it takes an enum that says 1 equals frame, 2 for caption, 3 for sprite, 4 for grid. That's what I'm going to try to squeeze in at the last minute for this jam. And it's a virtual function. So the UI drawable, the abstract class, can't perform that. But every implementation, every derived class implements it with a different enum value being returned. So it's just an easy switch statement to get the derived class, and I think that's called the visitor pattern, where I'm able to poke into that class and get a different value based on what the derived class is without really knowing anything further about it. So the meat and potatoes for the rest of the night should be, I know this file is way too huge, but I'm not refactoring during the jam. These two classes at the bottom, basically the Python types I'm defining. That would be UI collection, that's an iterable, and its helper class, UI collection iter. So the iterator basically just holds the current index and returns the next one. That's how it would work in a for loop, or allow you to use the iter and next methods. I think that's how that works. Yeah, just calling next on an object. What you would call next on would be the iterator instance. So multiple iterators can point back to the same data store. They're abusing the convenience of those shared pointers, that I don't really have to worry about any kind of lifetime management. So I guess I'm doing reference counting in C++ and garbage collecting in Python, kind of abusing my performance budget, but hey, still getting tons of FPS on those 3 rectangles. So let's get into whatever I was going to do. Let me look at my notes. Here's the notes. Feeling pretty good about all those green check marks. Didn't really write any new notes today. This is all my to-do list from last night. It is pretty slow going. This is not easy stuff for me to accomplish. I've been using the heck out of ChatGPT. I have the API plugged into a Discord bot, so I've just been chatting on Discord and trying to leave my notes somewhere easy to find. I know ChatGPT, the website is free, but via the API I can mess with the system prompt a little bit, which I can tweak the way it behaves a little bit. And I'm also trying to rack up enough billing to get access to GPT-4 over the API. I could really put some horsepower into some custom applications that way. So UI frame type needs the helper, and the collection needs the helper, because what these guys have is shared pointers to a drawable, and I need to convert that into the class that it actually is. There's nothing on my headphones. Let's just take that off. It was only for sound check. Okay, so let's do that. Let's find, oh, another thing. Let's find all the warnings. One heading. That would be the warnings need to be fixed. And it's those same three warnings. My jank compile script is causing them to repeat. I'll put that in my notes. And that's just not finished implementations. So no surprise there. Still building, so that's good. Those are all in the UI, the gigantic, horrible UI file right now. And let me just poke my brain into UI.cpp and look at PyInstance. So this should, the caption and sprite ones aren't implemented yet, but I should be able to use PyInstance, pass the shared pointer directly. That will use a derived type function, find out what type it is, instantiate a Python object of that type. It's going to be, it finds each type, UI caption, UI sprites, UI frame, calls tpalloc. All that gives you is the correct amount of memory, but the only data that any of these things store is a pointer to their own specific data type. That's why everything's inside a shared pointer. It's not the most brilliant breakthrough in the world, but I think it was kind of key to me to being able to make any timely progress with the Python API. At least in the context that I need it. I really need to be able to have objects originated on either side of C++ or Python and be terminated when the last of those two is done with it. So it could start on either side and end on either side. Shared pointer was just the best thing I could figure out to accomplish that. So we're going to call PyInstance with back to UI.h. And where those match up with my two notes, that would be TP iter next on the iter type, dot children on the Pi UI frame. Pi UI collection iter type. Okay, so let's start with, it would be UI frame, get float members, get color member, set color member, and get children. Still returning null. This is one of the things to do. So this one, this children method, get children, is already a getter method. I have not opted for a setter method at this time. Interesting thing here. I think I need some definitions that are lower down. So here's what I'll do is I will give a signature here. And we move this down the file to where, let me just add a note because I'm going to be refactoring this hopefully soon. It's so ugly. Way too much stuff in this one header file. But that would be this would be a great case for having separate header files for all of the Python types, that they can include each other's definitions, and then the implementation is still separate because these two classes are crisscross dependent on each other. The collection could be a scenes user interface, or it could be the children of a UI frame. And a UI frame is one of the possible instances that could be in a scenes list of children. So that would be Pi UI collection. Which is where we're going next. Here's that type. So to do that, how did I just do this? It's going to be Pi object is what we'll return, but it'll be Pi UI collection object pointer. And the type would be will be a pointer to it. Pointer to the type we want. tpalloc just gives us the memory and gives it a reference count of 1 in Python's garbage collector. If O data equals and that would be self data children. I think that's it. By assigning it, that also should increase the reference count on the C++ shared pointer, thereby increasing the number of references to this collection. So the Python collection is a separate object from the UI frame objects, and hopefully that will just it stops the data from getting freed, but it's wastes space, but also is intentional, so things are not seg-faulted. They can be moved around without being recreated. Okay, so what else was there? Iter next. So let's see. Collection changes size during iteration, return exception. We go past the end, raise stop iteration, increment, get your data. Okay, so here's where we need the builder. And that would be hold on, where's my notes? Did a bad thing. Man, my notes are a mess. No, it was Obsidian notes. Where am I looking? Okay. So that'd be O. Oh, we should just return source. Dang, is it really that easy? If my code works, I guess. And let me grab a green check mark. That would be control reaches end of non-void. Got you. So likewise, get item. Ooh, where was I just now? So I'm going to borrow all this. It's going to need some heavy reworking, but I'd rather rework than rethink. Let's go to get item. This is the method that allows me to retrieve based on index. So if you use square brackets and you put in a number 0, you'll get the 0th member. I don't know if that will automatically allow like -1 or something for circling back around, but I can do that later. Right now I just want to get the basics working. I want to see the right instances for the whole collection. So okay, we have no start size, we have no stop iteration, we have no index. Same vector structure. It's UI collection, not UI collection iter, but they have the same member name there. Okay, so that's another interesting text I hope to never see. That would mean that if we get this exception, it would mean that the data shared pointer had been reset on a Python object that was not deleted, which super spooky if that were to happen. Regardless, I hope to at least catch it instead of wondering what the hell happened entirely. So target would be index. Oh, and that's another option is if index less than 0 or I could do the reverse ordering now. Self data size. So what that might be wrong. Whatever. What's the out of range exception? Let's actually try one out. So if I say Python 3 and say L equals 1, 2, 3, I try to get L4, I get an index error. So let's find the pi, it's probably that exact theme. So let's do that. Pi exception index error. Yeah. Oh, dang it. I should just borrow that same text. List index out of range. Okay. Target is whatever's at that position in the vector. The vector is where the data is. So we get the vector. It's a vector to shared pointer to UI drawable. And PyInstance should take UI drawable and give us a Python object of the matching derived class. So that's get item. The other one is remove. So here it is. And is this actually supposed to return? Yeah, it should return PyObject because I'm just defining a method. So what does this say? Honestly, it looks like I guessed. Okay, if I paste right now, do I get the same stuff again? Nope. Alright, so remove and append both need the same kind of treatment. Let me return, I'll start on these next, but I would like to try to compile and see what's broken at this point. So append and remove will make the collection act just like a list. You'll be able to give a, I think I'm using remove wrong. I should call it pop or something. I probably won't. The idea here is to remove, you give an index like 0, and it will erase that guy from the vector. Or Maybe not. I haven't decided. I don't really know how erase works on a vector to say if that would be right. But the idea is to get rid of my reference to it, and if it's no longer referenced anywhere in C++, it'll go away, it'll be garbage collected. Cannot convert target from vector shared pointer UI drawable to shared pointer UI drawable. I need the index, target index. So let's go to 5G3. Target equals vec. I don't quite get that. What is the type of self-data.get on a PyUI collection iter? Let me just check my own understanding. That would be a standard vector shared pointer okay, and then the target would be that vector at an address index -1 because we just added it. That's how the iterator continues to give you the next thing. So why is that wrong? Oh, I know why it's wrong. Because the vector equals, that's a pointer that we need to dereference. Okay. What does this say? Oops, I put an extra underscore 599. 604, similar thing. Vec should be, dereference that guy. Okay, let me backpedal. 5 pointer dereference. So 59. Wait, what was the other one? 516. If the pointer exists. Okay. I think here is where we'll deref, then index. I don't know the order of operations on these, so that's a little bit of a, I hate prefix and postfix mixing. Oh, another one. PyUI collection object pointer. Yeah, I need to explicitly cast the pointer on line 719. Away we go. (521) and 602, same issue. try the same thing. No warnings, no compilation errors. Let's see if we segfault. Okay. Here's the big old test. What do I have is well, yeah, f equal mcr dot frame instantiate. So I have this frame, generates all its fields. Now let's zero child objects. So if I say, let's say c equals f dot children, segfault, son of a... Okay, so debugger. So I mean, the other thing I can do is put a bunch of print statements in the getChildren class or method, and yeah, you want to, was it trace back? Backtrace. There we go. Okay, so yeah, getChildren, obviously. Closure, nothing. Self equals that instance. That self worked fine. I was looking at the repr of it, so it's doing the same thing. Generic get adder with dict. I think that might be my function call getting passed in. So yeah, so here's main game engine. We're rendering the UI test scene calls the REPL every render, so you get a single frame and then a hold for the command line. That's how I'm testing the Python integration. Would also mean I can get stuff to draw if I can get all this stuff to work. Okay, so we loop, we type something in, run eval code objects, pyeval, get attribute. That would be when I type in .children, PyObject generic get adder with dict. I don't know what would be in the dict, but it looks like object in this case is my frame instance. And UI frame get children has a segfault. I guess I'm not getting more than that, so let's go to children, PyUI collection objects, PyUI collection type. I've never instantiated this thing otherwise. Oh, let's try something else first, which is the collection type and the collection iter type need to be added to the module. If the interpreter is not aware of my type objects, they're just structs that are being filled with values. If it's not able to identify that guy, then it may crash when processing it. So let's go to, yeah, and we're going to live dangerously. Just say PyModule add type m rfpydef PyUI collection type and collection iter type. It'll be fine. I do not feel like it will be fine. Ooh, thought about it for a second. Let's just take a crack at this. Ooh, ooh, ooh. Okay, so I have classes. I have children. Okay, that's very good. Okay, that is the fastest I solved this Python API seg fault in my entire life. Whew. Could do append next, so I can add new frames together, and let's do the API call to get a scenes collection exposed. So here's what we'll do. Go to Game Engine CPP. I have this method with a monster return type. It's we are able to fetch a scene's interfaces by its name. The name is a string. That's the map that the game engine stores scenes by. So this baffled me for a bit. What I realized is that I can't call this from the constructor because I'm searching a map for a scene of a given name. So you can't use that from the constructor of that scene. The scene doesn't appear in the map until it's done being constructed. Obviously, but like really not that obvious. So all we're getting is the UI elements, which shared pointer. The scene is responsible for initializing it and holding on to it probably for the entire time the engine's going to run. Let's make a Python function to get this. I think I started on one. Let's find it. I call it scene UI. I did. Okay, so it might actually even exist. Let's see. Did I screw up? Oh, vector has return size of so-and-so. And let's see if that still works. And do mcr_py.scene UI. Yeah, dang. Why is that? That's a weird way to put it. Return vector has size equal to. That's the top level objects on this scene. So that does work, but I don't want to print out the size. I want to return an object built on top of that. So to do that, let's look at, this is the API stuff. This is the game engine stuff. Let's go to UI, and I'm going to look at the way children does it, and we're going to do this inside scene UI. already forget how to do it. Maybe I have it in a note. Yeah. Pi error. Set string. Pi exception. Oh, finishing another partial thought. What would this be? Scene C string. Actually use the string the user types in to fetch that from the map. Pi exception. Runtime error. If I was super cool, I would put the input into the error text, but and when we do this, what I'll put for now is using namespace self-data children would actually be UI, I think. Yep. The whole collection. Data that. That's all it should take. Wish me luck. So if this works, I should be able to change the size of the UI frames that are already on screen by getting their objects and modifying them. Let's see what happens. There they are. So let's say scene UI. Okay, good. C UI collection 2 objects. What's that? Index 0. A seg fault. Yay! Oh, that's I was almost on a roll there, wasn't I? That's break time. So, you know, let me just say drawings. Oh yeah, that's not bad. So let's see you in a bit. All right, let's get back to work. Am I back at work yet? Okay. Oh, seg fault. Great time to let's go back to work. Yeah. Okay. What did I do wrong? Oh, that's get member called. Let's see if it was in my code. So, symbols. No, I should turn this on. There we go. All right. Oh, we compiling. Not build, debug. Run. So for that, I should say mcrfpy dot scene UI test. And Pi instance. What the heck? Ooh, that's very cool. Use count 4. I like that it says that. That's okay. Source equals shared pointer class UI drawable. Yeah, that would be child 0. Well, ooh, what would the 4 use counts be? So that should be the scene, the copy that got sent to Pi instance, the one that constructed the collection. I don't know what else. Maybe there's one in use for like get items that have it. I don't know. Let's see what get item says. All right, get item. Yeah, I guess it's in Pi instance, but that's really weird that there's like an extra thing in my traceback. What does that even mean? My volume, good. Yeah, it's maybe even a smidge high. I don't like seeing it turn red, so let's try to keep it in the, just poking into the yellow. There we go. We're quitting. We are going to Pi instance to print some stuff. That's really weird. Why is my stack pointer all off in La La Land? What was going on there? Okay. Let's go to UI, CPP, Pi instance, Pi UI frame objects. Oh, so source and OData might be 2 different ones if it made it this far. New object equals Pi object O. While we've got this object, let me say, so it must have done that, right? Like that's the only thing it could have possibly done. Let me say, can I call repr straight on this thing? Let me just, I would like to use my repr function and just spit it out, but I mean, that obviously is not ready to work yet, so excuse me. All right, so me just say source is a shared pointer to UI drawable. This box a pointer now. Nope, just children. Box dot, okay. That should be enough data for me to at least like recognize which guy it is. So then let's, I think there was like exactly one person watching the stream while I was on break, and I started talking and they left. Brilliant. Average view duration 5 seconds. Killing it. Okay, that says class UI drawable has no box. Okay, so let me also say static pointer cast. Let me look at what this does, because that might actually be the issue. So I don't want a, like I don't want a bare pointer stored in data. I want a shared pointer. Returns a copy of SP with its stored pointer cast statically from U to T. If SP is not empty, the returned object shares ownership, increasing by 1 the use count. If SP is empty, you get an empty. Okay, so that's actually doing what I thought it was doing. Let's say my frame should have done it with debug symbols. Didn't print nothing. Static cast not possible? Yikes.
Ooh, come on. We are getting somewhere. I can feel it. Okay. The magic word last time was mcrf py scene UI test. Actually get item. Okay, so we got the UI frame case, and it crashes, it seg faults before this C out. So I'm gonna add 2 more. And then this would be what? So we're going to just try and get exactly which line is causing the issue. It's a very simple static cast being done. I should be able to just turn a drawable into a UI frame, no problem, assuming it is a UI frame. Where's that put us? UI frame case. It's crashing on TP-alloc. So it might be crashing on that. Although that also seems pretty harmless. I'll go find that guy. Seems like it didn't complain about allocation. UI frame case. Pi UI frame type. .tpalloc. Pi UI frame type 0. Am I doing TP-alloc correctly? Let's consult ChatGPT. Oh, same system prompts. I will risk it to put my Discord bot on screen. I don't mind if you guys are able to find me. Let me find my system prompts. This is the one I like recently. So what am I going to do? Give it a system prompt. And now I'm going to tell it about my issue, which is Is it a static instance of what? And at the bot. Hopefully it cooks. So the API has been annoying lately. Nope, looks like it didn't cook. No, okay, I was just too impatient with it. It says okay, boilerplate. Never heard of PyObject new. Maybe I'm just not reading enough. PyObject new macro handles memory allocation, initializes the object properly. It didn't really, I don't think it really answered my question. UI frame objects. UI frame type dot tpalloc. Was it done this way other places? So let's find my other tpallocs that use another type, because if you call new, if I say UI get children creates a collection object. Am I just missing a address of operator? That no. Let me just see if this is part for part identical. Object type is UI frame object somehow. No, that one's been working fine. Pointer to type object, tpalloc, pointer to type object, and items. Maybe I am using it wrong. Why did it work in the other circumstance? Oh, this calls. I provide that, don't I? What's the difference between UI frame TP alloc and so here's UI collection type, and that TP alloc is not defined. TP new, that's pi color, pi UI frame object self equals TP new there, but these don't define TP alloc. Pi UI collection iter type TP alloc. Pi UI collection type has init and new, which actually don't cooperate for this class. It's not supposed to be something you can make a new one of. That seemed, let me try that too. So before I just focus on that one seg fault, so let's say mcrpy dot scene UI same issue, it's not instantiating them right. Am I not able to do that? I know what type it is. Let me do this again. Error return without exception set, and that would be in for a caption. No, all the contents need to scoot. Okay, that looks better. Okay, and now this will at least give me a chance to say can I do a not yet implemented? Not implemented error. So let's, and I can say Brutal. Yep. I messed up. Those types aren't even defined yet, so. Have at it. C equals mcrpy dot scene UI UI test. C1 is a UI caption case seg fault. Oh, UI caption case returns null. So returns null isn't being handled by who calls it? This guy way at the bottom, get children? No. It's a couple of places. PyUI collection, get item, return PyObject, return PyInstance target. I mean, that should be able to return null just fine, so why would that seg fault? Let me see what else it does. New object. I don't know why I should have to specify that, but oh, what is that actually returning? It's returning a null pointer when it should be returning a shared. No, it's returning a PyObject. Ay caramba. Okay, that looks better. Is it dangerous to repeat? So, not like a error that I can see from repetition. I think I have to go answer the distress call of a baby. His mama's got him. All right, let's try to regain my train of thought. Okay, that one works fine, not dangerous. That one presumably too, but I don't have an instance to test it on. UI frame. This part right here seems to be throwing a seg fault, and UI frame type. Trying to get a new UI frame. Let me see if there are any more of these. Let's go to the header file, and it should be used in plenty of places. Well, not that many, I guess. Just the type object. And I never defined a TP-alloc on it. But I never defined a TP-alloc on the other ones too. I thought that's supposed to get us like this static type objects should get like generic function pointers when the interpreter loads it or something. I thought. I don't really know the nuts and bolts behind that. But we got TP new, which I could try what ChatGPT told me to do, which is call a macro for new. Let me try that. I don't know why it's not working this way though. If I don't understand, I can't really comprehend why I shouldn't do it. Whatever. Let's try the frame object, PyUI frame object type TP-alloc pointer to static instance, just a single one. So let me instead say PyObject new PyObject. What does PyObject mean in this circumstance? Address of Py UI frame type. Let's see if that does anything different. Because what I should be able to do then is take the UI frame object, it's a struct, rip out its guts, and replace it with that. My brain is seeing some problems with it, but I don't really know enough details about it to determine if I have good instincts or not. Okay, this says cannot convert Py objects. I really needed to put a conversion on the front of it, didn't I? Obviously. Got to do that in front of everything. It's creates an object of that type. You just got to tell it that it's not a generic Py object pointer when you do that. Unfortunately, means build again. Okay, so ooh, casting data. I think that's farther than we got last time. Yep. So that worked now, casting data. This is not working. Let me try this hack. Standard shared pointer UI frame. I don't know. Static UI. Static. Static pointer cast. Seems right, but the thing I'm doing now is I forgot. Let's hopefully see if it oh, compilation failed. Real annoyed with trying to cast that. Yeah, no matching function to call for. Yeah, I didn't like that. What are some other things I can do besides static pointer cast? Let's continue that same. How much should I give ChatGPT? All right, let's continue talking with AI about it. So was it UI frame? Come on, ChatGPT. I don't know how to fix it. Nope. Source is a shared pointer. On data, standard static pointer cast, UI frame source. Did you just? The corrected code is exactly what I sent it. Shared pointer UI drawable, the shared pointer UI frame, you need to use static pointer cast directly on the shared pointer object. Feel like I'm taking crazy pills. Let's see. That's the source. UI frame source. All right, let's try that thing. Casting data casted assigning. So it's really the assignment of that data. Oh, data. PyUI frame object. Let me just double check the definition. A lot of uses, but here's the struct. Well, that's a copy of the struct. UI frame object, shared pointer UI frame data. That's all there is to it. So the only thing I can think of is O is a. Let me find the docs for this guy. I'll try to pull them up the old school way too. Googling. Fields not defined by the Python object header are not initialized. So nothing surprising in there. Let's see. What it has different here is allocate a new Python object using the C structure type and the Python type object type object. Type should be a pointer to the PyType object that represents the type you want to create. So that should be, oh, and I'm using this as a meta type. So this is not, we want to pass this and nothing for the meta type. Okay, let's try that. And then hopefully get to delete a couple of print statements and streamline this a little bit. It's not on fire, I don't think. No, okay. Spoke too soon. What does that say? Expected primary expression. It's in Python. Do I need to give it a structure? Like, is that? That's not what, like, the documentation is terse in Python. It's like, great, that's a completely logical explanation. But when they say type, I think it's a, let's see. C structure type, Python type object, PyType object pointer. PyUI frame object. I mean, that is the C structure type. That's the structure. But like, this is a struct too, isn't it? This is an instance of the PyType object struct. So when they say type in all caps, do they want the type or do they want the object structure? I don't know. Let's just try every permutation. Should only be 6 or 24 or something. Casted assigning. Let's also ask ChatGPT. What does it say now? And this macro expansion is not producing a human parsable output. Like I give some weird stuff here. It needs a type PyObject maybe, which is what it was originally, I think. Try to get it to do some self-correction. Let's see. TP basic size. Was that wrong in my PyUI frame type? PyUI frame object, that's what it's allocating. It's got a deallocator, which calls TP free, also not defined in this struct, just relying on base behavior. Okay, so we want a pointer. Yeah, I've got no clue. And I still think this is a distraction from this TP alloc thing, which works in plenty of other places in the code. UI frame case never gets to cast. It never gets past this. Is there any PyUI frame type TP-alloc in my never used, but UI collection type. It's let me just say .tp-alloc. Type TP-alloc when the pointer to the type is provided. Cast that into the object. Type by pointer TP-alloc. So maybe it's not passing my type back. It's the same data type, but maybe once this gets ingested, because this is what I pass to the module, what it starts passing back would be different. Like it actually has these additional things assigned on it. So I need to figure out how to get those other type objects, because I don't think there's any other the only place I use it is in new. Okay, so here's color type. Okay, this is a strategy. Again in new. So let's try this. No such thing as a night off from being a dad. Does that match what the other one said? The color one. This is what PyUI frame does to generate colors, which should be very similar. Reinterpret cast. That could be handy too. Color type TP-alloc. Oops. Okay. Let's try it. Wouldn't say it looks good, but wouldn't say I'm hopeful. That's what gets me. Semicolon. Story of my life. Okay. TP Alex still causing my seg fault. Okie dokie. Well, that's where I'm going to stop tonight. Not great, not terrible. I'm sure with some sleep, this will not seem so outrageous. Maybe I'll even figure it out.